So this is a support video for the S3 and National 4 Analogue Electronics section of Engineering Science, and just now we're looking at Task 8. Now if we read Task 8 in our booklet, it says that an engineer wants an electronic circuit which will make an output light up when a switch is pressed. The engineer produces two designs, which are circuits A and B, and they're showing up on our screen just now. Now, one of the starting points here is the fact that circuits A and B have got a different kind of voltage supply from what we've seen before. We're not using a battery anymore, we're using something called voltage rails. And there's a voltage rail here, where we've got a 9-volt supply at this terminal, and which is also connected to 0 volts down at the bottom terminal here. Now, the circuit here on the left hand side is the same as circuit A. The only difference is that we've used a 9-volt supply battery to supply it instead, which forms a ring. When we get these voltage rails, then basically all it means is that these ends are connected into something which would have formed the rest of the ring to form the series circuit somewhere else. So the circuit we've got here with the battery supplying is exactly the same as circuit A. Voltage rails, for if you need to build circuits in Yinka that are using voltage rails as a supply. If we go into the lab equipment folder, power supplies, and we can find a voltage rail for 9 volts, and we can find the 0 volt rail for completing the circuit there. And as with the batteries, if you needed to change that to a different voltage supply from 9 volts to something else, you can select it and change the value to suit whatever voltage it is that you require. So, new component that we're looking at here in this particular circuit is the component that's labelled X. And this component is something called a diode. And a diode is a really important component in electronics because it allows us to essentially control the flow of current. The current in circuit A and in B will try to flow from the 9-volt rail all the way down to the 0-volt rail. But diodes will only allow current to flow in one direction. And the little clue to the direction that will allow current to flow in is that if you look at the symbol itself, it almost looks like an arrow because of the triangle with the point. And that's basically showing us what way that will allow current to flow. So this diode in circuit A will allow current to flow from 0 volts up through the arrow up towards 9 volts, but current won't flow that way because the current is going to try to flow from the 9-volt rail down to 0 volts. And if I close that switch, hopefully we're looking for the lamp to light up, and when I do that, then we can see that the ammeter's showing 0 amps, nothing's happening at the lamp. Now, another little clue that tells us roughly what's happening here with a diode is if we look at the symbol for the diode, it's got a little line going across there. And that line is effectively acting like a barrier or a gate, which basically means that when the current is trying to flow from the 9-volt rail, it hits the barrier and can't go any further. So, as well as having a bit of a clue with the shape of the symbol, which is showing us what way it will allow current to flow in, the barrier, if we think about the current flowing from the 9 volts rail down to the 0 volt rail, the current's going to hit that barrier and can't go any further. However, in circuit B, our diode this time is connected round in the opposite orientation, so the arrow from the triangle of the symbol is pointing down the way. Now that sounds promising because, as we stated earlier, the current is going to try and flow from the 9-volt supply down here, down to the 0 volt rail. If I close the switch, this time we can see that arrows are showing where the current's flowing. It's getting through the diode, through the ammeter, and the lamp's illuminated. If you need to build your own circuits using diodes, then we can find them. And if we go into the electronic components folder, analog processing, discrete semiconductors, and there's a diode right there. And again, if you need to change direction, you can click on it, grab the handle, and put it into whatever orientation that it is that you require for your circuit.